It says sketched below are the graphs of F and G. F and G intersect. Okay, I'm just going to look for the interesting things. Usually they're just telling us everything we can already see. Blah, 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 blah. Okay, there's nothing important there, guys. You can read through it yourself, but there's nothing important. And now let's quickly see here. So question 6.1, determine the coordinates of the turning point of C. Now, guys, that's very easy for you guys. I'm not going to waste too much time there. There are two ways that you can do it. You can either use calculus and you make the gradient or the first derivative equal to 0, or you can use the turning point formula from grade 11. I'm going to use the turning point formula from grade 11 because it's a parabola. I know that I can do that. So the turning point of a parabola is minus b over 2a. And so they've given us the equation up over here. And so I'm just going to quickly race through this because for most of you, this shouldn't be too bad. And so that gives us 2. So the x value up here is 2. Then to find the y value, you just plug that back into the original equation. And so that's going to be minus, always in brackets, guys, wherever. Some students, it's a very small mistake, but some students do make this mistake quite a lot. They put the minus in the bracket and then they square. And that makes your question completely wrong. Look here, guys, this minus is not it's not part of the x. It's its own little thing. So you rather go minus, then you put the x in a bracket. Only the x goes in the bracket like that. Okay, plus 4 times 2 plus 5. And that should give us 9. Yes. Okay, so that gives us 9. And so we have a y value there of 9. Pretty straightforward. Next question, write down the range of f. Now, the range is the y values. And so we can say that the range will be all the way from minus infinity up to 9. So you can either say y is an element from minus infinity up to 9, where the 9 is included. But then some students like to use, you would rather prefer to use this method. So you'd say y is smaller than or equal to positive 9, like that. This one says, oh, I love these questions, guys. The reason I love them is that, oh no, never mind. It's not the question I was looking for. Never mind. That's awkward. So this one says, calculate the length of AB. So they just want this length over here. So that's easy. What we do is we just find the two x-intercepts, which are there and there, and then we'll easily know the distance. So finding the x-intercepts, I'm sure most of you are okay with that. You just make y 0. And then you solve. Now, you can solve this by using the quadratic formula, trinomial, using the brackets, whatever you like. I'm going to be lazy, and I'm just going to use the quadratic formula. But this one could definitely factorize. Definitely, definitely, definitely. I'm just going to go plug it all in on the calculator so long. Okay, x is 5, or x is minus 1. Now, a little piece of advice. When you get your answers in the exam, have a look and see, does my answer make sense? So this x value is minus 1, they say, and this x value is 5. But if I maybe got x equals to minus 5 or x equals to 1, then something doesn't look right. And that can easily happen by leaving this negative out, for example. So take a few extra seconds if you can, and just make sure, does that make sense? Because this does seem like a minus 1, and this does seem like a positive 5. All right. Okay, so the length of AB, you can use the distance formula if you want, but it's unnecessary. The reason it's unnecessary is that this is horizontal. So we can easily say the distance from minus 1 to 5 is just going to be 6 units. And so there the answer is 6 units. Question 6.4, determine the equation of G. So that's really easy as well, guys, because it's just a straight line. And we know how to calculate equations of straight lines, right? To do that, we need 2 points. And so we know this point already, point B. It has a coordinate of 5 and 0. And then we just need one other point. So I think we could possibly use this point over here. because that is the y-intercept of the parabola. And we have the parabola's equation. So to find the y-intercept, we just make x 0. And that would give you 5. So that means that this coordinate here must be 0 and 5. Then I can easily work out my equation of the straight line now by first working out the gradient. And so that would be equal to 5 minus 0 over 0 minus 5. And so that's going to be equal to -1. So I now have that y is equal to -1x plus c. And then to find c, I can just substitute any of those 2 points into the equation, and I should end up with -1x plus 5. All right, guys, so let's move on now. 6.5. They tell us that point T, which we don't have on the diagram just yet, T is a point on F, okay, so it's somewhere on this graph, such that D and T are reflections over the line CVN. Okay, guys, so this is a typical type of question. So they're taking this line CVN over here. Okay, wait, that was a bit skew. They're taking that line, and then what they're doing is they are taking this point over here, and they are going to reflect it across the line to that side over there. And so obviously the y value will remain the same, you see, because the y value, the height does not change. And so what we need to do quickly is we just need to calculate this distance over here. And so that distance would be 2. How do I know that? Because this x value is 0, and this x value is 2, because it's the same as the turning point's x value. And so that horizontal distance would be 2. And so this horizontal distance on the other side would also be 2. And so if you had to look at it carefully, we should find that this should be 4 and 5. Right, so here's our next question. It says the line EC, okay, so let me highlight that for you guys so we all know where it is. EC is over here. They tell us that it is a tangent at C. It says write down the gradient of this tangent. Well, this tangent, we can see it's a tangent over here, and we can see that it's a completely flat line. And so it's going to have a gradient that is equal to 0. So the gradient will be equal to 0. Okay. Then it says determine the coordinates of E. So guys, if you look carefully, this line is completely horizontal. It's completely flat. So the y value of this point and this point must be the same because they're on the same horizontal level. Okay, or the same vertical level, sorry. So guys, if we look at point E, we know that it has the same y value as C. So we don't know what the x value is, but we know that the y value is 9. Now that point E is a point on, it's a point on this line over here that we calculated, okay? And so we know what the equation of that line is. Remember, we calculated that in an earlier question. So the equation of G is equal to -x plus 5. So we can plug in the y value of 9. And then we can calculate the x value. And what we should eventually find is that it will be -4. So the x value is -4 and the y value is 9. This question I think will be quite interesting. It's a nice 5 marker and they're talking about tangents and stuff. So that's always interesting. So let's have a look. So it says determine the value of k for which y equals to -x plus k is a tangent to f. Okay, so guys, if you can see this correctly, y equals to -x plus k. So the line, this line that we had earlier was y equals to negative x plus 5. So can you see that these two gradients are exactly the same? Okay, but it's only the y-intercept that is changing with them. So that means that we are going to be looking at these random lines, and those random lines are going to be parallel to the tangent, or parallel to this line here, because they all have the same gradient. Okay, and we would like to find the value of k so that the line is a tangent to the graph. So all of these lines that I'm drawing now, these are not tangents. Why? Because a tangent only touches the graph in one exact place, okay? And all of these lines seem to be cutting twice. But if I can get a tangent, if I can get a line that does that, okay, wait, not exactly like that. Not exactly like that either. Like that. Can you see that it only touches the graph in one little place now? And so all of a sudden, that would make it a tangent. But now the goal of this question is to try and work out the equation of that line. So some of you might be thinking, well, how does that work? Well, there are two different ways. So the first method is the following, and I think a lot of students like this, and this method can be used in many different questions, and it goes like this. We know that because it's a tangent, it means it is touching the graph, right? It is touching the graph. How do we normally find the place where two graphs intersect? How do we normally find that? For example, how would you normally find this point and this point? Well done if you can remember that you would make the two graphs, or you would make the two equations equal to each other. And that is exactly what we are going to do now as well, because these two graphs are touching each other. So if we want to find out where they touch, we make them equal. So I'm going to say minus x squared plus 4x plus 5 equals to minus x plus k. Minus x plus k. Now, of course, you cannot solve this equation because there's two variables. But don't worry, I've got a little trick that I'm going to show you guys. But for now, I'm going to get everything to the one side and make the other side equal to 0. Now, some of you are sitting there and you're like, okay, but Kevin, now, what now? How do I actually solve this? Because there's a k, there's x's, what do I do? Well, here's the interesting thing, guys. This is where nature of roots becomes very, 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 very powerful. Remember that the discriminant, which is known as the b squared minus 4ac, depending on what that is, determines a lot of different things. For example, if that thing over there is negative, if it's negative, then we call that a no solution. So what that would mean is that we're trying to see where the two equations are equal to each other. If there's a no solution, then it means that they are never equal to each other. And so that would be a situation where maybe the straight line is doing this. See, the straight line is not touching the parabola. That is what that would mean, okay? So if they ever ask you, find the value of k so that there is no solution, then you would make these, you would still make them equal to each other, like we did here. But then you would try to make the discriminant, or the triangle, the b squared minus 4ac, you would make that a negative. Because if it's a negative, then it means there is no solution. Now, if that answer is anything positive, or even if it's 0, then there will be a solution, because we call this a real solution. But now we get 3 different types of real solutions. We get, if it's equal to 0, then we call it real and equal. Another one for equal is there's only one solution. There's only one solution. For example, x equals to 3 or x equals to 3. That is what one solution actually means. There's only one type of answer. Then if you get a number like 25, 36, 49, any perfect square, then we call it real, rational, and unequal. So you get two different answers, like x equals to 1 and x equals to 3, for example. Then if you get any other number like 18, 19, 24, then you're going to start getting ugly answers like decimal answers. Then we call it real, irrational, and also unequal. So that would be like x equals to 1.4 or x equals to 1.2, for example, okay? If we want this line to be a tangent, then which of these do we want? Do we want the discriminant to be negative, or do we want it to be 0? Do we want it to be a perfect square, or do we want it to be a non-perfect square? Which one would be the most suitable for this question that we are busy with right now? What we're going to do now is we're going to take this equation that we made, so minus x squared plus 5x plus 5 minus k, and we are going to go find the discriminant, which is this one here, the b squared minus 4ac. So that would be, so because we want to make the b squared minus 4ac, we want that to be equal to 0. So we're going to say 5 squared minus 4, a is minus 1. Now here's where the k comes in, because the c value is 5 minus k. And we're going to make that equal to 0. There we go, guys. I hope that that makes sense. And so I'm just going to take this here and carry on. So that's going to be 25 minus 4 times minus 1, and then 5 minus k. So I'm just going to multiply these two numbers together quickly. So that will become plus 4. And then that's all equal to 0. Then I'm just going to multiply this in like that. And now I'm going to go and solve for k. So I would end up with minus 4k equals to minus 45. I then divide by minus 4, and I end up with 45 over 4. And if you would like to do that to the decimal, 11.25 is your answer. 11.25. So let me show you the second method now. Okay. Here is method number 2 for a question like this. And you probably will get something like this in your exams. I've seen this type of question in many, many, many function exam papers. It's usually the last question, or at least the second to last question. And it's normally 5 marks. Okay. So the other method, guys, to find the equation of this tangent is to remember the following. Let me write this out. I'm going to write it out neatly for you guys. Okay, so here we go. The gradient of a tangent is always the same as the gradient of the graph at the point of contact. Okay, so that's something that you always need to remember. The gradient of a tangent is always the same as the gradient of the graph at the point of contact. So the gradient of this tangent will be the same as the gradient of the graph at the point of contact. So what's really, really, really nice is that if you look at this equation, we can instantly work out what the gradient of the tangent will be. The gradient of the tangent is minus 1. We can see that. So we can say gradient, or actually m of the tangent is equal to minus 1. So therefore, we can say that the gradient of f of x is also equal to minus 1. at the point of contact. Okay. Now, here's something else I want to add. Most of you understand this, but I'm just going to type it. To find the gradient of any parabola, cubic, or any other graph, we use the first derivative from calculus. Remember, the first derivative is another name for gradient. So I'm going to take the parabola now, which is this one up here, and I'm going to take the first derivative because I want its gradient. So I take the first derivative. By the way, some of you sometimes get confused when they use f minus 1 and when they use f with a little line. Remember that the minus 1 stands for inverse, which is something totally different. And then this one stands for the first derivative. And that's what we are busy with now. Okay. And so if I take the first derivative, I get minus 2x plus 4. Now, what do? Do I make the first derivative equal to 0? Because that's something that many students always want to do. But then that means you're not really understanding it. Remember, we're not going to make it equal to 0. Because if we make this part equal to 0, then what you are saying is that the gradient is 0. But it's not. We said that the gradient is going to be minus 1. So I put a little minus 1 over there. Then what I go and do is I solve. I solve for x. And so that's going to end up giving me 2x is equal to 5. And so therefore, x would be equal to 5 over 2. So that's not the answer. What that is telling us is that the x value at the point of contact is 5 over 2. Okay. What do they want? The value of k. Okay. But we don't know the y value. We don't yet know the y value. So what we have to do is we need to go and plug, because it's not 9, guys. Remember, we're not looking at point C. We're looking at this little point that's just next to the C. And so to find the y value, you would plug that x value into the parabola's equation. You can't plug it into the tangent's equation because we still don't know the value of k. So we're going to plug it into the parabola's equation. And if we go work out that y value, we get 8.75. You see, guys, so we're not exactly at the 9. We're close, but that's not where we are. So we have 8.75. So what we can now do is we can go plug this 8.75 and the 5 over 2, which is the same as 2.5. We can plug that into this equation now of the tangent. And so we can say y equals to minus x plus k. And so we can now say 8.75 equals to minus 2.5, which is the same as 5 over 2. And then we say plus k. And so if you had to go work out k using this method, we also get 11.25.